All right, this is the density lab. I call it Eureka because that is what Archimedes uh, supposedly shouted when he came up with the concept of density and how to calculate it. Basically what it is that there are several different objects at each table. We're going to have a digital balance to measure it. You do have a ruler because some of those objects we are going to need to measure with the metric side. That's those centimeter sides. You're going to have a graduated cylinder, a cup of water that you're going to use to put the graduated cylinder at 50 milliliters because we're going to need to measure the volume of some of the irregular objects. So at each table, or the materials that we are going to be measuring the density of are going to be an eraser, a little gemstone, a screw, a little like a pine wood. We have aluminum, we've got iron, and we've got nylon. So we've got these blocks back here. All right. So the first thing we're going to do is let's just calculate the mass of all the objects. So it's real easy. I'm going to go ahead and put the digital scale here so we can read that. It might be reversed in the video. But all I'm going to do is I am just going to place that weigh boat on the digital scale. And then I'm going to hit 0. So anything that gets added is going to be, that's what's going to be. I don't need to take into account for that weigh boat. So I'm just going to go ahead and place the eraser on there. So the eraser is, you can see it's 24.5 grams. Go ahead and place that gemstone. You can see it's about 4.6. I'm going to go ahead and place that screw, 3.8. Go ahead and place that pine wood. There we go, it's about 8.2. And then I'm going to place the aluminum. It's 45. Then I'm going to get that iron. That's 127.8. I'm going to get that nylon. So that is going to be 21.6. Good. All right. Well, now that I've done that, I need to find the volume of all the objects. So there is a graduated cylinder at each one. Fill it up to 50 milliliters. So you can see that you're looking at the meniscus. It's going to be at 50 milliliters. You're going to fill that up. Now, you have to determine how you're going to measure volume. Remember, there are two ways to find the volume. Number one, you can measure it with those irregular objects with the graduated cylinder, or you can calculate it by using equations. Now, we know the equations for the rectangular prism, which is what these are. So we'll go ahead and set those aside. Now, I already have some graduated cylinders set out. These are all ready measured at 50. Right? So I have three irregular objects. I have the eraser, so I'm just going to go ahead and place it. I'm going to put my hand over it just in case it does splash. I don't want to get any of the water up and above that. Oop, there we go. So if you look at where the line went to, it's at about 63 milliliters. So you can see that right there. You might be able to get a look at it if it focuses. All right, so it's at 63 milliliters. So now what I'm going to do is I'm going to place that gemstone in one. I'm going to just put my hand over it. There we go. And if I look at that, it went up to about 50. I'm going to say 53. Right? So it goes up to that 53. It started at 50. Now it's up to 53. Right? So you can see that there. Right? Remember, these all started out at 50. Now the last one, it's going to be that screw. So I'm just going to put my hand over it, place it in there, and I can see that, I mean, it went up to 51 milliliters. So all of these started at 50. Then we can calculate the volume. How much water did these objects displace when they were dropped into that? So once we do that, we step that aside. To get the objects out, you can just sort of pour the water back into the back into the cup and just grab the item as it falls out. So we'll go ahead and we'll set these aside just for now, because we do not need them or at least anymore. Can also set the digital scale aside because we already got the mass of them. Now, there are these 4 objects. They are rectangular prisms. So I just multiply length times width times height. So I'm going to use that ruler, and all of these, they're cubes. They're going to have the same length, the same width, the same height. So when I put them up to the ruler, you can see that, well, each side is going to be about 2.5 centimeters, right? 2.5 centimeters. Yep, 2.5 centimeters. So if you know one of the sides, right, they're all going to be the same. You just multiply length times width times height. That is what will get you the volume, right? So you can see there are photos that do have that, but I'm telling you that each one of these, the sides, is going to be 2.5 centimeters. So you can use that to find the volume of that rectangular prism. So now that we know the mass of all the objects, we got that with the digital balance, and now we have the volume of all the objects, you can use that density equals mass divided by volume equation to calculate the density. All right, so now the next part is we are going to be applying this. So at each table there will be a penny, right? A single penny. Let's move all this out of the way because we don't need these anymore. We do need the digital scale. We don't need these objects anymore. There we go. All right, so at each table there is going to be a penny. Right. Let's see. Measure the mass of the single penny. Find the volume of a single penny through the displacement method. Then use that information to determine well, what is the density of a penny, or what is a penny made out of? So what you're going to do, the first thing, let's see here. So here's the backstory. You are going to determine if the density of a single penny. At each table, there's going to be a penny. Measure the mass of the single penny using the digital balance. At the front table, there's a graduated cylinder with 20 pennies in it. So there's also a picture, but I also have this graduated cylinder that I placed 20 pennies at the bottom. The graduated cylinder started with 50 milliliters, just like all of these. Now I dyed it blue so it's easier to see that water level. The graduated cylinder started with 50 milliliters of water before the 20 pennies were placed in it. Use the displacement method of finding the volume of a single penny. Calculate the density of a single penny. Then determine what material the penny is composed of. All right, so the first thing I'm going to do is this scale. Well, it appears to still be, still something happened with there. I'm just going to zero it out again, right? So I can go ahead, place the penny on there. It's 2.5 grams, right? So that is the mass of a single penny. The mass is going to be 2.5 grams. Good. All right. There we go. All right. All right. So now we need to find the volume. So this is the graduated cylinder that I placed the 20 pennies in. It started out at 50 milliliters. And you can see the water level now. I can see the water level is about 57 milliliters now. So I placed 20 in there. Now, that one's kind of tricky because there's 20 pennies in there. I ask you to find the volume of a single penny. So whatever you got for the displacement, whatever you got for the volume of all 20 of those pennies, you're going to need to divide by 20 to find the volume of one single penny. Now, once you know the mass of one single penny and the volume of a single penny, then you can calculate the density. Now, there is a list of different metals that you can compare that density to find out what a penny is composed of. So now the next section. Just like the story of Archimedes, the king wants a crown made. The king gives 10 pennies to a smith to turn them into a crown. The smith returns with a crown with a mass of 25 grams. You place the crown in a graduated cylinder with 5 milliliters of water to determine the volume of the crown by displacement. So there's also a picture off to the side. Calculate the density of the crown to determine if all 10 pennies were used to make the crown or if the king is getting ripped off. So if I look at that picture, well, the graduated cylinder, it starts at about starts at 5 milliliters, right? So this is a much smaller one. You place the crown in it, and it goes up to a certain level. So you'll be able to see that in the picture that's on there. So once you know, the mass is given to you, 25 grams. Now, once you figure out the volume of that crown, you'll be able to find the density. Once you find the density, then you'll be able to figure out what the crown is composed of. You'll be able to tell whether the king is getting ripped off or not. And that's that last question. You're supposed to say, were the 10 pennies used to make the crown, or did the smith rip the king off by using a different metal for the crown? Explain how you know this. So in that one, you're going to have to compare the two densities, the two materials, what the pennies were made out of and what the crown was made out of. So once again, this is our density lab, and I call it Eureka.